In this video, we will do the Gauss Jordan elimination to this matrix. Notice that this matrix comes from that system, but in order to do the Gauss Jordan elimination, a matrix doesn't have to be related with a system of linear equations. To start the Gauss Jordan, you can start here. You draw a horizontal line and a vertical line, and then you look for the first column of the matrix that is below the horizontal line and to the right of the vertical line, in this case this column, and we look for a pivot, and I think this is a good choice for a pivot. Then let's swap these two rows. Then we do, the notation is row 1 is interchanged with row 2, and then we get 1 0 2 negative 2, 2, 3, 1, 4, 3, 3, 3, and 3. Now we use the pivot to put zeros here and here. Then I can accomplish that by changing row 2. We change row 2 by adding negative 2 times row 1. And then I can change row 3 by adding negative 3 times row 1. When I do that, I get this matrix. What row is not going to change? Row number 1. 1, 0, 2, negative 2. Then I multiply row, to change row 2, I add negative 2 times row 1. That means negative 2 plus 2 is 0. Negative 2 times 0 plus 3 is just 3. Negative 2 times 2, negative 4 plus 1 is negative 3. And negative 2 times negative 2, it will be 4 plus 4 is 8. Now we change row 3 by adding negative 3 times row 1. Then we multiply by negative 3 and add. Then we get 0. Here we get 0 times negative 3 plus 3 is just 3. Negative 3 times 2 is negative 6 plus 3 is just negative 3. And here we get negative 3 times negative 2 is 6 plus 3, it would be 9. Now we move the horizontal line, we move it 1 down, and the vertical line, we move it 1 to the right. We do this. And then we notice that we have to search for a pivot in the matrix that is left when you do that process. Can I find a pivot in the first column? And I think either one of these can be a pivot. Let me switch these two rows and divide this by 3 so that I get a pivot with a 1. And I'm going to change row 2 with row 3. And then I will get 1, 0, 2, negative 2, 0, 3, negative 3, 9, 0, 3, negative 3, 8. And then the goal was to make a 1 here, and then I will just change row 2 by 1/3 of row 2. Then I will get 1, 0, 2, negative 2, 0, 1, negative 1. I'm multiplying by 1/3, yes, 3. And here I get 0, 3, negative 3, and 8. Now I use this one to put zeros in the rest of the entries of that column. This is already 0, then I have to take care of this, and I do that by changing row 3 and adding to it negative 3 times row 1. Then when I do that change, this first row stays the same. Here we have 0, 1, -1, 3. And here we have 0. When I multiply by -3 and add, I get 0. -3 and add, I get 0. And when I multiply by -3, I get -9 plus 8 is -1. Then the procedure says the following. Move the vertical line 1 unit and the horizontal line 1 unit. Then I will get this, right? This matrix here. And then I search for the first column that is left. Notice that I have forgotten about this. I have to search for a pivot here. Can you find a pivot? No, there is no pivot there. Then I move the vertical line and I try to search for a pivot here. Can I find a pivot here? Yes, this can be changed into the pivot. Then I have to make this entry a pivot, and I do that by multiplying by -1 row 3. I write that change like this, negative row 3, and then the first row stays the same, 1, 0, 2, -2. Second row stays the same, and the third row stays the same. Oh, sorry, it changes by -1, which means that here I get 1. Then we continue the process by using this pivot to make these two entries equal 0. Then we accomplish that by changing row 2 by adding -3 times row 3, and by changing row 1 by adding to it 2 times row 3. When we do that, we get the matrix. This row is not changing, 0, 0, 0, 1. And then when you multiply by -3 this row, nothing changes here. It would be 0, 1, -1, but here you get -3 plus 3. It's just 0. And here we get 1, 0, 2. And when you multiply by 2 and add, you get 0. And then the horizontal and vertical line were there. When you move it, the vertical line to the right and the horizontal line down, there is no matrix left. That means that this is in reduced echelon form. Let's find the number R and the sets D and F. We have that R is the number of rows with a pivot, and here we have 1, 2, 3 pivots. That means that R is equal 3. D is the columns with a pivot, and what I mean is the indexes of the columns. In this case, we have that the first column has a pivot, the second column has a pivot, and the fourth column has a pivot. And in this case, D would be the set 1, 2, and 4, and F is the set that takes care of the columns without a pivot. And in this case, this set is the set with the number 3, because only the third column doesn't have a pivot. Okay, in the case that we were interested in solving this system, we know that the augmented matrix of this system is this one, and these two matrices are row equivalent. That means that the system associated with this matrix is equivalent to this system. That means it has the same solution. The system is this one, x1 plus 2x3 equal -2, x2 minus x3 equal 3, and when you have here, you have 0x1 plus 0x2 plus 0x3 equal 1. You can see that this system, regardless of what is x1, x2, and x3, this third equation is never true. That means that in this case, the system is called inconsistent. Then if I ask you for the solution is just the empty set, which is written like this, or is written like this. That means empty set. And if I ask you if the system is consistent or inconsistent, in this case, the answer is this system is inconsistent. That means that it has no solution. Notice that the question of inconsistent or consistent is a question that is related with a system. It's not a question for a matrix. Okay, in this example, this system ended up being inconsistent with no solution. And if we are only worried about matrices, the reduced echelon form of this matrix is this one. Please do this homework.